I got it. You saw the video? I recorded the
Good morning, ladies and gentlemen. How are we doing today? Good, wonderful, awesome, excellent. Put away your phones, put away your headphones, ladies and gentlemen. Take out the green periodic table test that I gave you last week. If you weren't here, I have one sitting here waiting for you. All you got to do is let me know. Anybody need it? You don't? Well, look in the last place you had it.
Yeah, I checked.
Well, then it's not the last place that you had it. Okay, you need that and you need this, ladies and gentlemen. You need that and you need the table to write on. Okay, so here's the plan, ladies and gentlemen. We are going to give you about, let's go with 30 minutes. Then we will go over it. Then I will give you the second one that we will go over tomorrow. And then on Wednesday, ladies and gentlemen, on Thursday, you will take your final, which will be something similar to what you are doing now. The biggest difference between what you are doing now and what you are doing on Thursday is that on Thursday, you will not be given like AA is a third period noble gas. It will be the element named after the scientist who created the law of octaves, is a third period noble gas. So again, ladies and gentlemen, we had gone over everything that was on here on Friday. If you weren't here, I suggest you either get that from somebody or during this work time, you come up and you ask me about the ones that you are missing. We did give some notes on Friday. They were on forces, intra and intermolecular forces. So the notes from Friday, the video will cover that. It's probably about a 15-minute section of class or so. It will cover inter and intramolecular. It will also cover van der Waals and London dispersion that are on this yellow list. If you need extra of the periodic tables that are like this or that are like this, they're up here, ladies and gentlemen. You can come up and you can grab them. Otherwise, ladies and gentlemen, go to work on that practice test. If you have questions, raise your hand, call me over. We'll be happy to come over and assist you. Your choice if you want to work with somebody, but understand that on Wednesday you will not be sharing a brain with someone. You will have to do this on your own. So, your call, your choice, ladies and gentlemen. Please remember also that on Thursday for your final exam, if you are more than 15 minutes late to class for your final exam, I shut the door, I lock the door, and I do not let you in, which means you will have to find a time to come up and make it up in the afternoon. So please don't do that because I don't want you around on my afternoon when you don't have to be here. So, questions? Okay. By the way, I might as well get them out today. I will give you your goggles because you're done with them. And you can take them home with you. Use them however you like. If you don't want them, you can leave them with me. And I will gladly donate them to a worthy cause. My sales and my profits. So. There is a motion. Check. Hey,
No, actually.
Josie.
Hands like a fish.
Hey, Michaela. Sorry, that was a bad throw. That one was my fault. Angle.
Yes.
Ariana.
Oh my God,
Kenzie.
I don't want to talk about the yellow lab.
Josh. Phoebe with a smiley face.
That's just like.
That's just weird.
Joshua. We'll go with that.
Oh, Violet is the most reactive.
Yes.
Wait, so I don't have Violet. So it's like,
It's part of the electromagnetic
I
spectrum.
mean, it's gotta be in.
Yep. So a question may be like the form of visible light with the shortest wavelength, highest energy, highest frequency is this. Yes, sir. Yep. Okay. An atom of JJ is larger than a pion, but JJ ion is smaller than a pion. So what does that tell us about the what? It's a smaller ion than pion.
Oh, no, iron refixes.
Which ions are smaller in the same period?
Exactly.
Metals are always smaller in the same period because remember, they lose electrons, go down one energy level. Non-metals gain electrons, go up the next higher level.
Yeah.
Down a family means this way. Across a row means this way. So like down a family would be lithium, sodium, and potassium. You're going down the family.
It can be a plus or minus 4 as oh, wait. Oh my goodness. Oh, yes. Well, isn't that basically hardly? Oh, either way, it's okay. Okay, so it is very similar to carbon.
So in elements, gas. What? Something like chlorine.
You got it.
Ionization energy over it. Assuming it's the first ionization.
Okay, I think they're not okay. They're not cool. These are something wrong with the small would be first and then the big would. I think it's always never. Oh, so he
Well, here's the thing.
and
You don't fit.
where's it? Hold it. Oh, yeah. That'd be
Right there.
and then it goes next to the feet.
There's two of them, that would mean that P would have to be a negative 2. Because +1 and -2 would provide a 2, 1 ratio.
Oh, for you would go.
That's that P minus 2 spot. That's the 16. You just go and do 50. So, what would it have to be? Where are the man-made ones? Where are the ones that have not yet been discovered? Well, that one's discovered. That one's discovered. then he doesn't go there. Well, that's what beats anything after 82. What's the food for?
This is the
Okay.
That's the most. That's the most oxidizing.
Why you put it down at the bottom?
Most best oxidizing agent
Yeah.
is so yeah, study.
It is. Yeah, they both.
You put it in.
Yes, sir. Families go up and down. Yep, that's the same family, even though some are middles and some are not. Families go up and down. It doesn't matter which side of that line you're on. Oh. No, alkaline would never react slightly with water. They react violently. Which one? Alkaline or alkali? Alkaline, yes. I'm sorry, I thought you said alkaline. If you said alkaline, that was wrong. Alkali react very violently with water. Alkaline do react slightly with water, yes. Eric?
I forget. Did we write down what was time?
Well, I give it to you. Also, I told you helium. I don't know if you wrote it
Oh
down.
yeah, I don't think.
No, because I can see the spot with helium is blank spot. That's
Yeah,
on the other side of the periodic table.
Oh no. Yeah,
The one you're holding in your hand has another side too. The one you were just holding in your hand
oh, that's right.
has another side too, but you didn't bother to write it down.
Yeah.
Okay. Do you need the green one too, or do you have the green one? This one? You want these? There you go, Peter.
Oh, that's good.
Yep. Did you read the first clue? Did you read the first clue? Yes. No, did you read the first clue? It tells you all of these are in a certain period on the periodic table. Now, what I would do is I would have written them down next to that period. So that way, when you get to the part where it says, okay, it's in this family, well, you know what period it's already in, you put it in that spot. Oh, see, these clues sometimes go together. That's it. Yes. Well, there's got to be one of these two, right? So right now, I would read this one, and I would read the next clue.
Yeah.
Okay. So. Okay. So. Correct. Okay. means O could go down here too, correct? Okay, well, let's go back to that. O has a larger atomic radius than T. O needs to be below T. So T cannot go here and O cannot go here, right? Why? One of those spots has to be here by. So where does T have to go? Be up there. Okay, so now put O down here. Again, next to N, you can still don't know which one to read the next two. So sometimes you're going to get to it in an area. I won't leave you hanging though. The next clue, because you're right, you still can't place those. Next clue you get. Listen. What? Inert means unreactive. So it's a what? Correct. Okay. You go from the metal to a non-metal. In other words, non-metals in the same period as metals will have a larger radius. So they're filling up, for example, silicon is going to fill up the third energy. However, aluminum right next to it is going to lose all of its third period electrons to go down to the right. Atomic radius. Atomic radius is radius. It do need to do force. Because here's the thing, you're finding that sometimes the glue doesn't get you into a spot. It gets you into a few spots. But I'm not going to leave you hanging. So then the next glue should help. Maybe two glues down help. But I'm not going to give you clues to get you into an area and then not tell you how to place you within that area. It may take 2 or 3 clues for you to do it. Well, I would look at what ionic and what covalent or atomic radius gives you across the period. Also, which one doesn't? Well, see, that would help. Because the definition of an atomic radius, what happens to an atomic radius is you go across the period, you get smaller. What happens to an ionic radius smaller until you get non-metal. So the non-metal becomes larger.
Oh, no. I think, oh.
And then becomes smaller. If you move this down,
Oh, that long.
yes. Well, I don't think that.
What is it? Because it's a-
No, that's telling you that one goes to metal and one goes to non-metal. Yes.
This is the exactly that is really.
Yes. Z minus 1. So, for example, chlorine has 17 electrons. What if we got minus 1 electron? So it would be the same as argon. Okay? So Z plus 1, or Z minus 1 is correct.
No, I go 6. Because almost. So all your closest, you go second. One has a larger radius. What has to be the charge of P? Remember, so the charge of the compound is always 0. Now, us doing that with the covalent compound really has to be ions. Yes, yes. Okay, well, here's the thing. So, the larger than GT either before or where? Below. Always in the AA wants to be then forms. Yeah, that makes sense. Well, it says it's a it hasn't been just.
Hasn't been discovered yet means it's manual. If on there I say it hasn't been discovered yet, that means it's manual. Sorry.
That's okay. So it would be like, oh no. Oh yeah, right.
Oh, yeah. The metalloid is now, you can be a metal and a metalloid, or you can be a non-metal and a metalloid. Metalloids are different. go is here in order. Okay, so then there's 4 spots. So, every quarter, this quarter is the order of the next grade. So, this one is the heaviest. This one is the lightest of each one. Good. Excellent.
Oh. Okay, but E is an unreactive gas that is radioactive.
It can't go in 5. Why can't it go in 5, Eric?
Unreactive. E is an unreactive gas that is radioactive.
Okay, when do the F's fill? No, they exist in form. When do they fill? What period do they start filling in? There is a difference between when they exist and when they fill. Same thing with these. There is a difference between when they exist and when they fill. Yes. For success, not exist. How be the You're right. So there's again, the 30th spot on there would be the 30th. The top right, top left. Josh, what can I do for you?
Oh, I see. I see what you're saying. Oh yeah. That's Yeah, it's a non. That makes sense because KK is
I would find out where what is there. In other words, atomic radius. So you are in a smaller atomic radius.
it goes in groups. It's in the city. It's the same period. I feel like these
Non-reactive.
And then
Yeah. Oh. Oh, yeah.
When did the orbital start? Earlier than that? Trace it at the periodic table. The regular periodic table. See where it started. These go one behind. So there's only one spot for it.
Oh, I think I see that. Oh, I think I know what this is.
All right, ladies and gentlemen, let's go through this real quick. Okay, before you do, take out this periodic table. This one. The one that has the row period trends on it. I want to add something to it real quick, ladies and gentlemen, something that is going to be helpful to you. You probably don't have much on there. Okay. There is a difference on the periodic table to where the third or the d electrons, the ones in the third suborbital, the d, there is a difference between when they exist and when they fill. d orbitals exist in the third period. You can't see that. Thank you. D orbitals exist in the third period. D orbitals, I'll zoom in on it. Nope, I know. D orbitals exist in the third period. D orbitals fill. I'm working on it. There you go. Jesus, you are needy people. So while the D's exist in the third, they do not start filling until the fourth. F orbitals exist in the fourth. When do they fill? Not till the sixth. Okay? Questions? So that is an important distinction, because if it says that there are no d orbitals, that could be the first three periods, because the d's do not start filling until d4. If it says there are no electrons in the d orbitals, that's the first three periods. If there are no f orbitals, or no electrons in the f's, that is the first five. Yes, they exist in the fourth, but they don't fill till the sixth. So you have to read the question very carefully. Questions? All right, let's get this done, ladies and gentlemen. We've got 24 minutes, I believe, or something around there. So question number 1, ladies and gentlemen. Atoms A, F, K, P, U, Z, Z, E, E, and J, J are all third period elements. So A, F, K, P, U, Z, Z, E, E, J, J are all third period elements. So I put them by the third period. F is the most reactive metal in its period. So F goes first. ZZ is the most reactive nonmetal, so it goes in the halogen family. If you need explanation, stop me. Otherwise, I'm going to keep rolling. K reacts slightly with water to form a base. That is the alkaline earth metals. EE can be a +4, -4 as an ion. That is the group 14. An atom of JJ is larger than an atom of P, but a JJ ion is smaller than P. JJ has to be a metal compared to P being a nonmetal. That is the only way it can have a larger atomic radius, but a smaller ionic. I don't know where P goes yet. It could be in one of these. The only reason I was able to put JJ there is because it has to be a metal. Questions? P combines with F to form F2P. F in this case, F would be a -1 charge. If the formula is F2P, that means this has a total of a -2 charge. P has to have a +2 charge. This is where P has to go. Again, I'm going to keep rolling unless you stop me for more explanation. A has a full valence shell of electrons. That's the noble gases, which means U has to be in the last spot that was not used. Questions? All right. Again, if I do that to you, where I give you a bunch that are in an area, I'm not going to leave you hanging. It may take a few clues, but I'm not going to leave you hanging until the end of the test to come back and place those. Okay. Element B has the highest ionization energy of any element. That means B is where helium goes. Element C has the highest electronegativity of any element. That is the spot where fluorine goes. D is the most metallic of all elements. That's where francium goes. E is an unreactive gas that is radioactive and has electrons that fill the f orbital. That means it could be in either one of these. They both have electrons in the f orbitals. They are both radioactive because anything past lead is radioactive. G is also an unreactive gas, yet it hasn't actually been discovered yet. That is because we had to create it in a lab. If it hasn't been discovered yet, that means that it is man-made. That is these ones at the bottom. I think I've taken that out and rephrased that on the test. But if it hasn't been created, that's the same as being man-made. Okay? Hasn't been discovered means it's man-made. Which means that if G goes there, E goes there. That was the only two spots where E and G could go. L is the lightest of all elements and can gain and lose an electron. That is the spot for hydrogen. M is a fourth period element with one valence electron. Fourth period, everything in the first group has one valence electrons. N is in the same family as M, and it is more reactive. N has to go down here between these two spots. I don't know which one yet. They're both more reactive. O has a larger atomic radius than T. Both O and T are alkali metals. So O has to be below T. N is taking one of these two spots, so O can only get one of these two spots. But what that means is that T has to be up here. Has to. It's the only way O can be below it. N has a lower ionization energy than O. Ionization energy decreases as you go down. N is lower, so it is below O. Questions? AA, BB, CC, and DD in increasing order of mass are in the same family as P and are more P is more electronegative than any of them. So P has to be at the top. So therefore AA, BB, CC, DD. Now you may be sitting there going, okay, I kind of get that. What would be a good clue? The forms of visible light are in the same family as PP and more same clue. What did it say? More electronegative. And they're in order of increasing wavelength. They're in order of decreasing wavelength. They're in order of increasing energy. So now, red, yellow, orange, blue, all of those, you would have to put them in there. Okay? Questions? II is a fourth period nonmetal. It is often considered to be a metalloid. Fourth period metalloid that is considered to be a nonmetal means it's on the right-hand side of the bold zigzag line. FF, GG, and HH, arranged in order of increasing ionization energies, are all fourth period metals. Fourth period metals, which means they go here. Ionization energy, as you go across the periodic table, does what?
Increase.
Good. So, FF, GG, HH. KK is inert and has no d orbitals. That has to go here. Why? Because d orbitals exist in the third energy level. Okay? It can't go here. They're filling here. LL is a halogen in the same period as G. So, LL is a halogen. That is going to be here. Here's G. So, LL has to be next to it, to be in the same period as it, but a halogen. Z -1 has the same number of electrons as E. So Z has to be right before it. Somebody had a hand up. Was there a question? Z -1 means it's going to gain one electron and look just like element E here. O +1 is isoelectric to W. Here's O. As a +1, it would be isoelectric to the noble gas at the end of the row above it. X is in the same period as K and reacts to form, X is in the second period and reacts with K to form KX.
Is W supposed to be down one or?
I don't believe so, no, because if O is here as a +1, it is going to look like the noble gas at the end of the row above it. X is the second period element and reacts with K to form KX. K would be a +2. X would have to be a -2 to be in a 1-to-1 ratio. Y is an element that was found in the last family of elements to be discovered. What family was the last group to be discovered? The noble gases. Why? They were gases. They're invisible. They're colorless. They're odorless. And they don't react with anything. Good luck finding them. MM is in the same period as BB and only needs one more electron to fill its outer shell. So MM has to be a halogen to need one more electron to fill its outer shell. NN has an atomic number of 30. PP has 39 protons. Now, Jaden called me over about this one. Element 30 and 39 are not on this periodic table. That's zinc and I forget what 39 is. So, but it says, for this one and one clue only, pretend that D's and F's do not exist. So find me the 30th element. 2, 10, 18, 26, 27, 28, 29, 30. This is where NN is going to go. And 39 would be, 38 would be right below that. 39 is here, which means this is where PP is going to go. Do you understand that clue? All right. QQ is an alkaline, or I'm sorry, Q, R, and S arranged in order of increasing covalent radii. That's the same thing as atomic radius. Our third period elements, or sixth period. So, radii decreases as you go across. So, S has to go first, R has to go in the middle, Q has to go last. QQ is a fifth period alkaline metal. There's where that goes. RR is also a fifth period element and it has a larger atomic radius than SS, which is also in the same period. So there are two spots left, RR and SS. For RR to have a larger atomic radius than SS, RR has to go first, SS has to go second. Questions? VV is bigger than ZZ, but smaller than AA. The only way you can be bigger than ZZ is to be after it. The only way you can be smaller than AA is to be, you have to be below ZZ and you have to be after AA. This is the only spot that is left here, ladies and gentlemen. VV. WW and XX are right next to each other on the periodic table, but WW has 25 more protons than XX. That has to be here, ladies and gentlemen. This is the spot where the S's or the P's and, the D's and the F's are supposed to be, but they are not. So this is the spot where you would be next to each other and differ in atomic number by 25. WW would have to go there, and XX would have to go here. Those were the spots I pointed out earlier for you, where even though they're next to each other, they differ by 25. Up here, even though they're next to each other, they differ by 11. H and I are two of the heavier elements. That means they're going to be near the end of the periodic table. H is more malleable than I, so H is a better metal. I is less metallic, so it is after it. J has a higher third ionization energy than YY, OO, and TT, which are all in the same period. To have a higher third ionization energy, that means that you are stable after you have lost 2 electrons. That is the alkaline earth metals. OO is between TT and YY. YY is considered more metallic than TT. There you go, ladies and gentlemen. Questions?
You make it look so easy.
I should have been doing it for 26 years. I don't expect it to be that easy for you. But here's my question to you, and I'm very serious with that. What question did you see on there that you would like me to explain? Which is why, again, I said we have to go through this fast so that we made sure we got done. Here's your chance to say, okay, I don't get why you put AA where you did, or BB, or whatever. again, you will notice that sometimes I gave you a place for a clue, but not a very specific one. In a period, in a row, or between two spots.
Can you explain number 25 again?
I certainly can. Number 25. All right. When we're talking about compounds, so Kx, that has to be an ionic compound. Why? Because covalent compounds, you don't have to balance off charges. And I never showed you how to figure out how a covalent compound, why it's one of these and two of these or things like this. So if your compound is Kx, and you know what the charge of K is because it is here. K has to be a +2. What would X have to be to balance that out? A -2, because the total charge always has to be 0. We did the same thing up here with F2P. F is a -1, but because there are two of them, that means it's a -2 charge. I'm sorry, +2 charge. And this has to be then a -2 to balance it off. So the only way these balance off in charges in 0 is if one is a +2 and one is a -2. Well, -2 is group 16, so that was where we had to put X, because we knew it was in the second period. Or, yes, X. Questions? Okay, I'm giving you this because I'm guaranteeing this is going to be on your test. Okay? So, the element that you're trying to place has these consecutive ionization energies. Okay? Ionization energy is the energy needed to remove an electron. This is the first ionization energy. This is the second. This is the third. This is the fourth. This is the fifth. This is the sixth. Which one of these is out of pattern and why? And it's not an exact pattern. But which one of these is out of place compared to the other ones? Nope. Only one. Only one is out of place compared to the others.
Maybe the 380.
What?
380.
Why is that out of place, Phoebe?
Most of them end in 5, except for the last one.
Okay, nope. Good. Something different.
Is it that one though?
Is it that one?
Is it 380?
Nope.
Okay.
The second one?
Now we're just going to start guessing them first, then the second, then the third.
Yeah.
Yeah.
Why is the second one out of place?
First one to the second one is 2.5. And then
2.5.
Yeah, like 125 and 235. And after that is 0.5. Oh no.
I'll give you a hint. The 5 at the end has nothing to do with it, but you're kind of on the right track.
The fourth one,
Why the fourth one?
because it increased like 300, while the other ones only go 100.
Bingo! Here to here, 110 kilojoules. Here to here, 145 kilojoules. No, that doesn't sound. Yeah, okay. Here to here, we have 245 kilojoules. Here to here, 130. Here to here, 135. Where is the big jump? Right there. Which means we had a hard time removing which electron? Why would we have a hard time removing the fourth electron? Why do we have the hard time removing an electron, ladies and gentlemen? Nope, nope, nope. These are all in the same period. Nope.
More kilojoules?
That's why we have a harder time. That's how we measure it, with the amount of energy. Why would we have a hard time removing an electron? What element do we have the hardest time removing an electron from? Hardest time removing an electron from what element? Which one? Helium. The noble gases we have the hardest time removing the first electron from because they are what? Stable. What family do we have the hardest time removing the second electron from? Nope. Nope, not oxygen.
Noble?
Nope, not noble again. Noble we have the hardest time removing the first. What family do we have the hardest time removing the second electron from? What? No. Alkali. Why? Because when they lose one, they become stable like the noble gases. Now, go ahead and get it to give up a second electron. Doesn't want to, right? Okay. What family do we have the hardest time getting 2 electrons from? Sorry, 3. Back up. Hardest time getting 1 electron out? Noble gases. Way over group 18. Hardest time getting a second electron? First electron, second electron. Hardest time getting the third electron out? Hardest time getting the fourth electron out? Okay, come on. We went from here to here to here. Boron family. Which electron did we have a hard time removing here? The boron family. The boron family, right? We had a hard time removing the fourth electron. What family would that clue be in? The boron family. The one where we have a hard time removing it. Okay? The one where we have a hard time removing it. Now, I could have also said it has the highest fourth ionization energy. The energy needed to remove the fourth electron. Okay? Electron needed to remove the first, the second, the third. Energy needed to remove the fourth. Boron family. I just gave it to you in numbers instead of in words. Okay? Questions?
What do you want us to do with it?
You can keep it. I want you to keep it. I want you to have it out on the day of the test. I want you to use it if you need to. Take one, hand it back. The only way you get better at this, ladies and gentlemen, is to practice. The clues that you're seeing will become easier the more times you see them and the more familiar you are with them. Now again, ladies and gentlemen, you can use all of this stuff on your test. All of these notes, the practice ones, I don't care. You really think it's going to help you? If it does, yes, use it. I don't care. Phoebe, do you see Josie at all later on in the day?
No.
Remind me to give this to her tomorrow. Since she decided to leave early because she doesn't like me. You should have the back of this periodic table to use for the one that I just gave you, ladies and gentlemen. But you may want to make a note on this. This was table 1, this is table 2. Otherwise, when you're on the test and you're looking at it and they're not in the spots where you think it is, that might be why.
Which one? What? The blank one? Take that one there. You're welcome. Have a good day, ladies and gentlemen. We'll see you tomorrow. Goodbye.
Daily Cloud Hub,